Hello, everybody, and welcome to this month's Department of Energy Python Exchange. My name is Cameron Riddell, and I will be your host this evening, afternoon, morning, whatever it is, wherever you are living, whatever time zone you're currently in. As you all may know, our goal here is to have Python thrive within the National Lab system and associated research sites. And in support of that goal, we are joined today by guest panelists Juan and Draga from the Napari Python project, here to share how scientists can best leverage their work and engage in the open source scientific community. But before we get into the agenda and introduce our panelists today, I want to remind everyone of a few key points about these exchanges. This call will be recorded, edited, and posted online. As a consequence, please be conscious of the information and the questions that you may ask and ensure that you're not accidentally sharing anything that might be privileged or require clearance. Additionally, as you all know, we are a growing community and we would love to stay in touch with each of you. If you would like to be kept up to date with our monthly exchanges, please sign up for our mailing list, which you can find on our website, meetup.doepy.org. You can additionally find recordings of all past exchanges on this site as well as a recording of today's exchange once it has been edited and posted. For those of you who have never joined us for an exchange, I would like to share with you that these exchanges are typically broken down into 4 parts. First, we'll introduce our fantastic lineup of hosts and guest panelists so that you may all get to know them, as well as their respective fields and background. Second, we'll kick off into a coding activity where we'll ask some very applied questions to our panelists and elicit some practical discussion about the best practices in software development and where they might fit into the world of academic or science research. As these two worlds come more and more in touch with each other, we want to make sure that we are leveraging the best coding practices that we can and make sure that they are influencing us in our research in a positive way. Third, we'll turn things over to our guest panelists, who will share some prepared remarks on Python, Napari, and its use and uses across the many disciplines that a multi-image viewer has. I know I used to do work in neuroscience, and so we used, not Napari unfortunately, but we did use 3-dimensional image viewers to parse apart our functional brain data. Finally, to wrap up, we'll have a full discussion about the points brought up by our guest panelists. And for everyone joining us in the audience, this is your chance to ask questions and engage with our panel to help us all understand where Python fits into the life of a researcher and how you can engage with the Napari project. With all of that being said, I would love to go ahead and introduce our hosts and guest panelists today. For each of these introductions, I'll share the name and affiliation, and our panelists will tell you what types of questions that they are here to answer. So you should now be able to see my screen. And let me quickly rewind this. And this is our introduction, the Python Exchange Ask Me About. Our host panelists, I'll start by introducing myself. Hello, everyone. My name is Cameron Riddell, and while I'm not affiliated with a specific lab or project, I do have a background in academic research as I studied cognitive sciences in graduate school. For today's exchange, I would love to discuss any and all questions related to Python as a whole, or specific concepts and its uses in Python's vast scientific computing ecosystem relating to tools such as NumPy, Pandas, or Matplotlib. Next up, we have James Powell. James is affiliated with NumFocus, and James, what do you consider yourself an expert in? What types of questions are you here to answer for us today?
One of the types of questions that I really love answering is not just, does code quality really matter, but how do I convince a scientist that code quality might or might not matter?
Fantastic. Well, I'm sure we'll turn to you when the heat gets turned on for the coding and the programming side, because not every single researcher wants to be a programmer, but with the vast amounts of data that we deal with on a day-to-day basis, it's becoming more and more imperative that we at least pick up some coding practices. Next up, we have Dan Allen from the Brookhaven National Laboratory. Dan, what are you an expert in, and what type of questions are you here to answer for us?
Sure. I work on the Python project Blue Sky, which is a collection of Python-based projects that are being developed by facilities around the world. And I'd love to answer questions about how to facilitate ground-up collaborative software projects that let people share their ideas and their code and solutions to their problems. Thanks.
Amazing, Dan. We have a good number of core developers of various projects here, so I'm very excited to hear kind of the community interaction that we get from having so many kind of high-level maintainers on projects. Next up, we have Matt Carbone, also from the Brookhaven National Lab. Matt, what are you an expert in? What types of questions would you love to hear about today?
Hi, everyone. Yeah, I'm in the Computational Science Initiative at BNL. I guess I would say I'm an expert in numerical scientific computing as a general theme. So everything from machine learning to HPC stuff. I did my PhD in condensed matter, where I used a lot of computations and software to solve scientific problems. And I'm happy to answer any questions about that. Long story short.
Perfect. So we have Matt as our computational expert here. So when we get into crunching the numbers, I'm sure you'll be a great resource for us. Next up, we have Andy Barbour, also from the Brookhaven National Laboratory. Brookhaven is very much representing themselves well today. Andy, what are you an expert in, and what types of questions are you here to answer today?
I'm an expert in using Python to analyze data or making minimal code to make experiments possible. I work with users that scientists that know nothing about Python but want to analyze their data, all the way to core developers in Python. So I like to answer questions that help both sides work together.
Sounds like you'll be serving as an excellent bridge between our programmers and our researchers. Andy, you have the best of both worlds, and I'm very excited to see how your perspective on the questions that you bring up for our guest panelists later today. Next up, we also have Tanny Chavez from the Lawrence Berkeley National Lab. Tanny, what are you an expert in, and what types of questions are you here to answer for us today?
Hi, I'm currently working mainly on the development of machine learning algorithms and how to make them accessible for different scientists across LDNL and some few other national laboratories. I would love to answer questions about how we can use machine learning to optimize and do data analysis and processing in efficient and fast ways. So that's something I'll be eager to hear about.
Fantastic. I think we'll see a lot of these implementations in the talk today, and I'm very excited to hear about your perspective on machine learning and how that can help carry us forward. Next up, we have our guest panelists. We are joined today by Juan Nunez-Iglacias and Draga Doncila. Juan, let's start with you. I know you're from the Napari project, but can you tell me just a little bit about the Napari project and the types of questions that you're here to answer today?
Yes, so Napari started as a way to look at images that were more than 2D, for which we already had plt.imshow, which I still use a lot. Since then, it's grown to show a lot of related data. So, if you have an image, you want to detect key points on it, and you want to see where those key points are. So we can look at points that relate on images, and you can segment the image so you can look at the segmentation on top of the image. So that's where Napari is. I don't really consider myself an expert on anything, but Andy's profile sounded familiar, helping people use Python to solve their problems. And my background in doing that is bioimage analysis. But yeah, I don't discriminate, and I've helped users across the spectrum, and I'm here because I would like to help users across an even broader spectrum.
Fantastic. And yeah, as you mentioned, more than one field has the issue of, I have a bunch of images that I need to view, or I have multi-dimensional images, three-dimensional images over time, things like that. Yeah. And I need an easy way to explore and analyze my data. So I'm very excited to hear what you've prepared for us with Napari. And Draga, what do you consider yourself an expert in? And what types of questions would you like to hear from the audience and the host panelists today?
Yeah, I'm gonna go with Juan here. I don't know if I'm an expert in this, but I've taught Python a lot to sort of fresh beginners, people who haven't had any coding experience before, and I really love teaching Python. Not just Python, but Python's definitely an easy starting point to non-coders. So definitely feel free to ask me anything about that. I guess more on topic, definitely feel free about asking me about Napari, and not just how you can code up something useful, but how you can make people aware that there is something that can be coded that would be useful. Because I think, one of the big issues is just scientists aren't aware that code can help them solve some of their problems, even if they're not building it themselves.
Exactly. I think that's a huge issue that we see with academic software is one person comes up with this great, really useful tool or project, and then it just sits on GitHub and just kind of attracts dust, or it doesn't even make it to GitHub. It just gets published somewhere. And honestly, I don't know of many people who search publications, recent publications, for new software tools to use. So I'm very excited to hear that perspective and how you've helped and how you've used it to help grow Napari as a community and not just as a tool. With that being said, those are our host and guest panelists for today. And next in our agenda, I know that James has come up with an absolutely fantastic game for us to play. So James, I will turn things over to you.
Hello, everybody. My name is James Powell, and I'll be presenting this month's coding activity. And so to get us started, I'll share my screen with you. Behind me, you'll see my screen. I'll, of course, hide in the corner here. This month's coding activity is called What Does It Do? We're told that Python is something along the lines of executable pseudocode. We're told that it is a language that allows us to express our intentionality better than any other language. In this month's coding activity, we'll present our panelists with just enough code that fits on our screen, squeezing as much as we can in, and we'll ask them, taking no more than 1 minute and 15 seconds, what does the code actually do? And is it readable? Is it expressive? Are there any possible improvements? Is there anything that you like about this, anything you don't like about this? And so, to make everything just a little bit easier for our panelists, why don't I double share my screen so that you can see the code that we're about to display. And so, for all of you participating, you should now be able to see my screen twice over. I'll switch over to the code. I've tried to squeeze as much as I can onto one screen. There are some imports at the top. I'll just move past those imports because I think we can agree the imports probably don't matter. I'll put 1 minute and 15 seconds on the screen. Let's try to take a look and see what does this code actually do. Now, for those of you listening in, one of the things that we want to discover from this exercise is how does somebody who has a lot of familiarity with reading code actually read code? Are they going to read it line by line from top to bottom? Are they going to jump around a little bit? What catches their eye? What draws their attention? What tricks do they have for skimming more effectively? And how can we integrate that into our own work? Because when we have thousands upon thousands of lines of code, maybe more than can fit into one screen, we need these kind of approaches in order to be able to figure out how we can make small improvements, find bugs, or to extend that code for our own purposes. Now, panelists, I'll give you another 15 seconds or so to just get a sense of what this code does. I will, of course, leave it on the screen, and then we'll go around and see, does anybody have a sense of what the heck this code actually does? And is there anything that makes this code more or less readable? Anything that you like about it? And of course, how did you go about trying to figure out what this code was about? So just take a couple of moments and we'll proceed right now. Does anybody want to jump on audio and tell me broadly what this code does, or maybe where this code might live?
I'd love to take a first stab at this, James. To me, I typically would skip over that data class at the top. Data class just tells me that there's some entity that James is trying to track, and he's added a couple fancy attributes or methods to it. But I want to see how he uses it before I get into the nuts and bolts of what it is. So I see that he's gathering all files, putting those into a set using the pathlib module to iterate over a directory named data. And then I can see that he's instantiating a raw data class from the path that is passed in. So he's converting files into some type of data class. Next, he looks like he's stored some corrupt or files that he wants to not run against or not process.
So what do you think happened there?
based on their file names, you have a test and you have a bad run. So I think just for some reason or another, maybe you've already inspected the data by hand and just decided these ones don't need to be processed further down the line. So that's my gut instinct. And then it looks like—
Or he ran it and it failed and he edited it and then he ran it again.
Could very well be that. Is that not what we all do when something doesn't work on a file? You're like, well, I didn't even want to begin with. I don't need those data. But then you're limiting it down, right? You're kind of limiting down your all files and removing the skipped or corrupt ones and checking if they have a .input attribute or if input is not none or not false in this case. And then you're going through them, doing some processing, and based on the methods for .assign, .drop, .setIndex, I can tell that processors.reader returns some type of pandas data frame, or I would assume that much. And then I can see that you're piping it into a processor.writer, which is some output format. So maybe you want to output it in the same format that you input it. And then this is when I would go up to that raw data class and figure out what exactly is it doing. It looks like it's reading something in and being able to spit it back out as well. So it looks like the raw data is control of your I/O.
So let's pass it to another panelist. Do you agree with Cameron? Is that what this code does? Where did this code pop up? Go ahead.
Yeah, I would. Sorry, that sounds about right. I have no idea why it's called raw data when it's processing the raw data. I feel like if a class is called raw data, it should hold the raw data, if that makes sense. Yeah, so I think that tripped me for quite a while. And I think the imports are important. I don't know what the hell a processor is. I would go and yeah, right click on that thing and try to figure out what it was if I was reading this in a normal setting.
What changes might you make to make this more or less readable? How would you rate the readability of this code?
Yeah, it's interesting. Because regular expressions are like by definition not readable, but they're also useful. But yeah, when I first saw them, I'm like, oh, well, that's not helping. But you can't annotate regular expressions. So that might be something that I would look into. Yeah.
So you might put some comments in that regular expression so you can break that down.
Yep.
Did you get stuck on the regular expression, or did you skim over that and try and get a general sense of what the code was doing?
I wouldn't say I skimmed over it, but yeah, I skipped it. I skipped the array. Yeah, and then I saw a whole bunch of stuff, and then you do a rolling mean at one point, which yeah, again, doesn't really fit with my idea of raw data.
I'm curious to hear from Andy or Tanny. When you see giant blocks of code like this, where it's doing a bunch of analytical operations, how do you actually break that down to figure out what the heck did this person do? Imagine that a scientist has come to you and said, hey, Andy, hey, Tanny, can you help me with my code? I think there's a bug somewhere.
So I guess what I would do, especially if it was really complicated, is I'd get one file, I'd import the data by hand, and then just use pandas to kind of step through the process just to make sure I understand what each one of those things does exactly. I can tell about what it does, but not for sure.
Any other strategies for maybe trying to eliminate having to juggle all of the micro details at once, but maybe isolating portions of this code? Does anybody use... Oh, good.
One thing is I don't think the code is bad at all, because the biggest thing for me is there's nothing that's longer than, my rule of thumb is 25 lines. So each of the functions, each of the elements is short and sweet, and that makes it pretty easy to, figure out what's going on.
I think...
Go ahead, Draga.
I think it very much depends whether this code, so the readability of code, I think, is, directly tied to who is reading the code. So I wouldn't say this code is sort of a priorily terrible, but if this code was, designed to be part of a larger code base that someone else might maintain at some stage, it would benefit, I think, from at least some comments, if not, I don't mind that the data frame operations are changed like that. Like they're all formatted nicely, so that's okay. But a comment in there about what the overarching this processing is, I don't think would go amiss. Yeah.
Where would you call it quits on the comments? Presumably, if we want to keep this into one screen, we can't put a comment on every line. But where do you think the major area where comments might significantly change your 1 minute and 15 seconds of readability? Where would those go?
I would comment the data class itself and just talk about what its purpose is, because as Juan was saying, I don't think it quite is a raw data class. And then I would comment the big statement in that for loop, basically, and just say that the goal of this is to, it looks like, group things by hour and then take a rolling mean. Yeah.
Dan, Matthew, any comments about the readability of this code? How do we really live that reality of Python being executable pseudocode, self-documenting?
Well, I don't know if I'm going to speak to your second point real quick, but in terms of readability, I have a pet peeve, which I actually think is a discouraged practice. So it's not just my personal opinion, but I hate it when, there's no line numbers, but like date, comma, details equals, right? Then there's calling the datetime module, right? And there's calling mo dot group. Yeah, that is always real tough on my eyes. So that should be 2 lines. I mean, and usually a linter will warn you about this, if you try to do that.
Bear in mind, some compromises were made to just fit it into one screen, but go on.
Okay, fair enough. Fair enough. Okay, so I'll throw a second piece there, which I think has been touched on a little bit indirectly, which is in the last for loop. I don't actually think, it's hard for me to say actually, but I don't think you need to have all of that in kind of like one operation. You could probably split it up and comment it, and it wouldn't really compromise your efficiency. That could help the reader sort of better understand exactly what each operation is doing. Although these are, I think was said before, seem to be pretty standard pandas operations.
Yeah, and pandas users love their long piped operations. Does that make things better or worse? Juan, what do you think?
I like pipelines actually, to be honest, because you see the data sort of each step doing a thing. You've got a little walrus, which is a nice touch, but I don't think data is actually used. So potentially you can remove it.
I think this was to facilitate maybe Andy going, print data at the end.
Yes, sure. That's a good one.
Dan, any thoughts on?
Beyond comments, it's useful to have some tests. And when I look at this, something that jumped out to me first is there's too much in that main block. If that were a function, it's pretty well split up, but keep it on the main block so that I can more easily run some test cases on that, both for the testing and the sort of self-documentation of having some tests.
To wrap up our discussion of this code block, I have one thing that I would really love to hear from our panelists about. This code clearly is operating on some files on disk. It's reading them in, doing some operation on them, then writing them out. Probably part of some data pipeline, maybe taking some raw data and turning it into some processed form, or cleaning something up that came from a detector, an instrument, whatever the case may be. Is this code too technically sophisticated? It makes use of data classes, it makes use of pandas, it makes use of pathlib, it makes use of things like Python set operations. It has some advanced syntax like the use of the walrus operator. Is this too much? If they had written this in, say, 150 lines and eschewed all of those mechanics, would that make this more readable or not?
I personally would say yes, but that's because I've written similar things using OS and Glob.
I think it would definitely make it more readable. And certainly if your goal was to show this code to somebody else to teach them how to do something, I wouldn't go to this level of brevity. But again, I think it really does depend. What is the purpose of this code? If the purpose of this code is to go into a code base and be used, as part of a larger process, I don't think it's necessarily unreadable, but I would add some comments.
James, I have
I
a
would just
big picture question here. Who has the same data set in multiple different file formats? Right? You're doing the
No
same
one does that.
operations, assuming all of the same columns exist, but sometimes it's a JSON file, sometimes it's a CSV, sometimes it's a pickle file.
Whoever wrote this script presumably had it in one format and said, hold on a second, I have another data format that I'm having to deal with, and they had to figure out how to grow this in that fashion.
Yeah, I wish that sounded weird, Cameron. I really do, but I don't think it does.
For that oddity, are there things that the author of this code could have done to draw your attention to something that might be a little bit strange, that we don't even know what the data format is, we're having to figure it out from what's on disk? And what could they have done to draw your attention closer to that oddity of this? Maybe a giant comment sounds like the starting point. A warning, maybe, please don't work on this project, you'll regret it. Any other final thoughts or comments about?
The paths are hard-coded by the date, actually, for the files you want to skip.
Yeah. So, presumably they had actually done this, and they said, hold on a second, this blew up in my face, and so they marked some of these things here so they could eliminate them. Or potentially whoever wrote this for them, maybe this was written by you, Andy, and then provided to a scientist, you kind of gave them, some placeholders for them to eliminate things which, they don't have to come back to you and say, oh, this is corrupt, this is skipped, something like that. Any other final thoughts or comments, Matthew?
Yeah, I would only just add, as someone coming from, more of the science side, this code is actually pretty well written, I think. I've seen some pretty nasty code, and this one makes use of a lot of, best practices. There's not, 8 nested for loops, which I have seen before in Python code. It does, I love the constructing the set. All that syntax is great. So to me, this isn't half bad. I agree with all the other panelists. It could use some comments. It could use some documentation, but this is a pretty good standard, I think.
Any other final thoughts or comments before we wrap up our activity?
Yeah, I think I just wanted to add that I agree with everybody. I think that overall, I feel like the code is very well written and it's easy to follow. At the same time, I will probably see myself, like if I were to expect a scientist to keep developing this pipeline, to keep adding more things to it, maybe to place somewhere like a placeholder or something saying, oh, these are further methods that could go down the line, so that it will be easier for them to integrate further code, so that the keeping up or like updating the code itself doesn't rely on just like the person that officially or initially created this, but instead just to kind of like give it as a playground for someone else to keep adding more things. So just a thought, like a little thing as a placeholder or something saying, if you would like to further add more things to this pipeline, this is the place to do so, and something like that. But overall, I agree with everybody else.
Tanny and Dan, if you were to hand this code over to a scientist, would you be confident that they could pick it up and do, as you say, extend this, taking into account they'd have to learn what this means, what the regular expression's all about? Do you feel like that's what the lambda's all about? Do you feel like that's a reasonable thing you could expect?
Not really, unless they were already very good or very motivated to figure this out. I think I agree it's high quality, but it's one notch too complex for what it does.
I think I agree. I think that probably with some comments added to it, a bit more of a description, probably. But I think that if we were to expect them to add something at some point, or maybe like a placeholder, like a function or something that could be called upon, I think that would be a good spot.
So thank you to all of our panelists for their comments. I hope you all enjoyed this activity. If you have a block of code that you would like to have picked apart and reviewed in front of all of us at next month's Python Exchange, please do feel free to reach out to us and share that with us. The purpose of these activities is to help you develop better expertise, better intuition, better judgment, and better skills around the development of code, whether it is very sophisticated code like this or whatever code happens to fit into your workflow, into your pipelines. Thank you all for joining us for this. I hope you all enjoyed this month's activity.
Thank you so much, James. That was an absolutely fun coding activity, and I'm very excited to see what you have in store for us next month, or see who sends us their code to pick apart in front of an audience. Don't worry, it will be a safe space, and we will not be naming whose code it is. So feel free, please email us your code, and that email is doepy@dutc.io. Additionally, we should be moving on to our next item in our agenda, and that is up to our guest panelists, Juan and Draga. So without anything else being said, I will turn things over to our guest panelists. Juan.
All right. Okay, so I'm going to share my screen and just do a brief demo of like how to get started with Napari. The share screen button. Okay. Okay, you can see my screen? Very good. All right, so let's say you have a multidimensional image. So I'm going to do from scikit-image import data, and then I could say cells equal to data 3D. So now if I do cells.shape, this is a NumPy array, and it's got 4 dimensions. Now, if you're like me, you will have done this many times, which is import matplotlib.pyplot as plt, and then plt.imshow, and you just want to look at one slice of this thing, so you know what's in there. So you do cells of, let's say, 31 colon. Okay, and then you see this thing. But it's very hard to do this and look at many slices if you have a much bigger data set. So this is what Napari gives you. So I can do import, if I click back on that, import Napari, and then I can do viewer layer is equal. I'm going to get the two. I'm going to show the 2 channels at the same time. So this will return 1 layer per channel, and I can do napari.imshow cells. I'm going to say that the channel axis is axis 1 in this array. And so now we've got 2 layers here. This is the viewer, and I can very quickly slide through all of the slices of my array. By default, the layers are overlaid on top of each other with a translucent, and you can change the opacity with the slider, but you can make it additive, and then you can change the color maps so that you can see them both at the same time. So I'm going to make this one green, this one magenta, and yeah, now you can see both layers simultaneously. And the other thing you can do is you can switch to 3D mode, and you're going to see the slider disappear, and then you can see the image in 3D. So that's the basic thing. Let's look at n-dimensional images. Napari makes that really easy. One additional cool thing is that this is based on work from John Kirkham. You can look at Dask arrays this way, and it will only show whatever slice. It will only load whatever slice you're looking at. So I can do import Dask array SDA, and then say array is equal da.fromZar. And then I'm going to drag in this ZAR. So what is this thing? R is a Dask array. It's got this 4-dimensional shape. This is the 3D plus time volume, and it's chunked in this way. So now I can do your layer is equal to napari.imshow of this array. And this is now my Z slices through this array, and this is my time slices. And again, if I go to 3D mode, I can see a full 3D embryo, and I can move around the time points, and it's loading each time point as I move the slider. So this is 4 gigs, but I'm not using 4 gigs of RAM to run this. So that's the first stage. And now the next thing I want to show is how to use Napari to look at every stage of a pipeline as you're trying to process these images. So we're going to go back to cells because it takes a while to process that big task array. And we're just going to try to find, let me just do it again. Oh. The cells, should have kept it so I had the color maps. Let's go to 3D. You can see additive is nicer. Blending to green, and this to magenta. Okay, so that's our cells. Now we're going to try to find all of the nuclei. They're the round blobs. So to do that, I'm going to blur them. So I can do import filters. You can see I've gone through this, so I'm just going to use autocomplete to go faster. But here's a nuclei is not defined. That makes sense. Okay, so yep, nuclei is the first channel, and then we filter it, and then we're going to do find the peaks in there. So from scikit-image import feature, peaks equals feature peak local max of the Gaussian filter blobs. And so now what I can do is I can say the points layer is the result of adding points to my viewer. And I need to make the points themselves additive, not mistaken. Yeah. So that's all the nuclei I found. You can see that there's some missing. And so the next thing, so one of the things that I can do, you can iterate and change the parameters and see how that affects your segmentation. But the other thing you can do is you can annotate. And so if you change the points to display out of slice points, I'm going to go to the middle slice where you can see most of these points, and you see the missing ones. And now I can add some points to the viewer and manually help my segmentation along. So one of the things is this nuclei on the top left is splitting. So I'm just going to put another point here. And then I can keep going with my analysis. So I can say that my edited peaks is the data in the points layer. So that's just a normal NumPy array. Demonstrate that. Based on that, you can run a watershed segmentation on this. So what am I going to do? Let me look at my notes. I need a slightly less blurry image. So I'm going to filter with a smaller sigma. Then I do thresholded. That's not it. Foreground. So I'm going to threshold that Gaussian image, mask, and then I'm going to use the points to make some seeds. I'm labeling the point. So this gives me some seeds for my watershed, and now I can do my segmentation. This is somewhat distance transform. Sorry. Somewhat advanced image processing, but it is nothing that you can find on the scikit-image website. And so now I can do segmented. So that's my watershed, and I can do, I can look at the segmentation. So viewer, add labels. So we're trying to labels layer. Oh no, what did I do? Not segmentation, segmented. Okay, so everything should, what am I missing? This should be additive. There you go. And that's the segmentation. So that's sort of the basic workflows that you can do with Napari, which is to do some image processing, all multidimensional, and then look at every step of the processing along the way, which helps you guide and develop workflows that way. And the next thing is, what if you have developed a nice workflow and you want to share that with some users, and Draga is going to be talking about that.
Thanks, Juan. I'll take over the screen sharing. So Juan has done the segmentation and now with it, and we want people. So I'm inside a folder over here, and what I've got is Juan's code, which is actually just I think I prepared earlier, but it's a slightly tidied up version of the commands that Juan ran to produce his analysis. And then what I've prepared for us also is a very skeleton Python package, because all Napari plugins are Python packages. And what we've got inside that Napari watershed folder is just a Python module called Napari_watershed, because I'm not very creative, an init file, a widget file into which I've copied Juan's code, and then a PyProject.toml file and a setup.cfg. And if I open these up in VS Code, taking longer than not here, my bad. CD into Napari watershed, and then open that up in VS Code. There we go. So you can see widget has all of these commands, and setup.cfg and pyproject.toml are completely empty. And as I said, so far we've just got basic Napari, basic Python packaging file. But in order for this to be a Napari plugin, it needs one more metadata file, which I'm going to put in the module, which is called Napari.yaml. And I'm just going to prove to you that it is empty. There's nothing in there. And now we need to build our package, right? So the first thing I'm going to do is just add the typical Python packaging metadata. This is some build information. This is going to be a very quick demo, but I just want to show to you that you can build a plugin pretty quickly. So this is some build metadata. And then in setup.cfg is going to be the majority of our package metadata. And I'm not going to go into it in depth, but the only thing I care about is it has a package name. And what sets this apart from other Python packages is it has an Napari.manifest entry point. And that's what's going to tell Napari, once this package is installed, that it's not just a random Python package, it's an Napari plugin. And now that we've got this metadata ready, we're going to start building our widget. And we're actually going to build two widgets. And the first one we're going to build is going to just take an image and some points. Let's say we've added them manually. We haven't found them by peak local max. And then it's going to return a segmented image, right? That's what we're going to get. We're going to get those labels once we've run the watershed. And now I'm just going to sort of pick apart Juan's code and copy all of the bits that I want. So I want to run the watershed on the distance transform with seeds in foreground. Distance transform is there. And the seeds are there. I formatted myself out of convenience. And then the peaks, let's see, we have the seeds there. So that's done. The DT is done. And then we need the foreground. I'm going to copy the code that generates the foreground. But instead of generating it on less Gauss, which we're not going to have in this function, we're going to generate it on the image that we pass in. Oh, struggling. And then if I comment out all of this stuff, it should tell us what else we need to satisfy. Yeah, so we don't have peaks. The peaks are just going to be the points that we passed in. And we don't have nuclei.shape, but that's okay because we can just use foreground.shape for that. So this is now just a plain Python function, but we're going to turn it into a widget. And the first step to turning it into a widget, or at least into a Napari widget, is adding type annotations to our parameters and to our return types. Because that's what's going to tell Napari how to turn this function into a widget. And what we're going to return is napari.types.labels data. So these are Napari specific types that we've provided. And what this is telling Napari is how we're going to satisfy these parameters when it comes. So this is all that we need to do to the function. It's still just a plain Python function, but to make it a bona fide Napari widget, we need to hook it up via metadata in napari.yaml. So napari.yaml has some broad plugin configuration. It's just the package name and the display name. That's what's going to show up in the viewer. So you get exciting features like spaces and capitals. And then now we need to hook up that Python function to Napari itself. And we do that mainly in the way of contributions. Each contribution, roughly, has a command. And in the interest of time, I'm just going to copy in the configuration for our widget. So every command has an ID. It has to be unique across all plugins, and that's why it's prefixed with our package name. It has a title, which is just something that you can use for searching within the viewer, or you will be able to use for searching. And the kind of key part is actually this Python name. And all this Python name is a path to the function that we want to run when the user chooses to use this widget. So you see Napari watershed widget, Napari watershed widget. We go in there and we can find our watershed segment function. And as well as a command, we also need to add a widget contribution. And that tells Napari that this isn't just any random command, it's a widget command. We refer back with the command ID, we have a display name, and the key item here is auto-generate true. So we haven't told Napari anything about how to turn this into a widget. And the only reason Napari is going to know what to do is because of this auto-generate keyword. Now we should be ready, if I've done it right, to just install our plugin. So here we are. This is all of our metadata files and so on. We want to pip install in editable mode just in case I made a mistake. And when we run Napari, we can open up our handy cells image just from the viewer. We don't have to interact with Python if we don't want to. We can select our nuclei. We can add a couple of points. Bam, 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 bam. And then we can run our watershed. So this widget was built for us. All of the options were pre-filled for us. And if we run our segmentation, we can see it's obviously not great. So we're going to add our second widget, which is going to allow us to find the points with the peak local maxima, the same way that Juan did. Now, just in the interest of time, I'm going to just paste this function in. Again, it's just going to be a pure Python function. I want you to satisfy yourself that these could have been copied from this code up here if we had more time. And then there's only a couple of other things I want to point out about. First is that I've decided to take the sigma parameter because, as Juan mentioned, it could be really useful to try different values of sigma and see what's going to get the best sigma. So we've taken that as a parameter. And then because we're going to be returning multiple layers, we've put the data, some metadata about the layer and the layer type that we want inside a custom little Napari type called a layer data tuple. So that allows us to return both an image and a points layer, which is going to be our filtered image and the markers that we found. Again, if we want this to be a widget, we're going to type annotate it. And again, I'm just going to copy that in for convenience's sake. So we take an image data, and sigma is just going to be a float. I'm missing a typing import, so I'm just going to satisfy that there. And as we see, I'm returning layer data so that Napari knows how to turn these tuples into layer objects. And then the final sort of cherry that I'm going to add on top of this beautiful watershed cake is I'm going to provide some extra configuration for this widget. So this is no longer going to be a pure Python function. It's going to be decorated with Napari's Magic Factory decorator. I wonder if this is going to, no, it's not. It'll be from Magic GUI, import import factory. And now that I've decorated it, we have autocall equals true. And what that's going to do is every time these parameters change from the widget, it's going to just call the function for me. And then again, for added style purposes, I've changed the default widget type for a float parameter to a float slider rather than a plus minus combo box. That's a little bit more flair. Now that I've got my Python function ready to go, I just need to update napari.yaml again to tell it where to find this function. And again, just in the interest of time, I'm going to copy it in. It's formatted exactly the same. And again, this Python name just points to the exact function that we defined. And then the only interesting thing about the widget contribution is now that we've told Napari that it's a Magic Factory widget, we no longer need the auto-generate. So save all of that. We don't need to pip install because we installed in editable mode. And now if we run Napari, we should be able to run the full segmentation workflow. So we open our cells 3D, we find segmentation markers. As you can see, as soon as I opened the widget, it immediately ran. It ran on the membrane layer, which is not what we want. So we're going to switch it to nuclei, and it immediately runs again. I'm going to put it in 3D mode just so we can see all of the points. And what I want you to notice is that as I change the sigma slider, the processing also changes. We get the more blurry image and we get the points changing in terms of what's selected. I'm just going to kind of randomly go until I don't have in the background, which is probably a bit too far. I know that some of the nuclei are missing. I can add them if I want to. But all I want to show you is that now that we have some points, we can select our blurred data if we want, or our raw data. But we're going to select the blurred data. We're going to select the markers as our watershed seeds. And once that segmentation runs, we get our labels. And they're not perfect, but they're actually not bad. So that's all I have to say about plugins, except to take a little bit of 30 seconds to tell you that you can go to this link, bit.ly, Napari-ix, and you can learn a little bit more about the different types of plugins. It's not just widgets. You have readers and writers for custom formats and everything. There's a link to where you can find your own plugins and potentially share plugins in the future. You don't have to remember all of the different metadata files. There is a cookie cutter that you can use to generate an example plugin to play with. And then down here is just a bunch of other resources that we have for learning how to interact with plugins and build plugins and test plugins and pretty much everything else about plugins that you can think of. So hop over to that link, bit.ly Napari-ix, if you want to, take a look at these resources. And that is all from me.
Thank you so much, Draga and Juan, for those amazing demonstrations of an incredibly powerful tool. I would love to open things up for questions. So if anybody in our audience has a question, you can enter them in the Q&A widget on the side or bottom of your screen, depending if you're using the browser or native application. And while those questions are coming in, I would love to also have our host panelists ask any questions that they might have based on the demonstration we saw today, but also just maybe more broadly about the Napari project.
Every time I see this, I really wish this existed when I was a graduate student. It's so cool. I fought so hard to make it work in Jupyter notebooks, and it would have been just what I was doing fits completely into what you're doing. As you guys have had a couple years now putting this in users' hands, maybe a couple, what have you learned about how people want to use it that was different than what you expected?
Yeah, I don't know about that one.
I don't know if this is different to what we expected. It's what we wanted, but I think, well, for me, it happened earlier than I thought it would. Is with the Napari, we always kind of had this vision of Napari being a gateway to learning Python. So as Juan demonstrated, it's great to be able to have Napari and IPython side by side. We can kind of do some tweaks in the viewer and then do some analysis in IPython and have this two-directional behavior. And so that was kind of that carrot for people to join, the ecosystem and then learn a bit of Python and then, I guess, provide those tools in a Python free way via plugins, for example. Where the GUI is just as full-featured as doing it through code, but maybe the code, gets you more flexibility. And I think what we found with the rapid growth is that we have a lot more sort of GUI only or GUI mostly users at this stage in the game. And I don't know if we envision it happening this quickly. And so I think there's some sort of GUI interactions that are not, some of them are just missing, unfortunately. And some of them I think are not quite as smooth as we would have liked them to be by the time we got a large number of GUI users. But the ecosystem is growing really fast, and we do still have a lot of people. We have had quite a few people who came in as Python beginners and are now contributing to Napari and writing, complex workflows. So, it works, but it's definitely, I think, quicker than we expected.
I will say there's also a lot of people, there's a lot of uses that we didn't envision. The basic use that, we developed is still, I think, the most popular use of it. But like one plugin that I really like is Napari animation, and it lets you like pan around in 3D and change the views and make layers visible and invisible and like generate a movie out of that. And people do that to show off their data for papers and things. That was totally outside of my radar when I started working on this. And there's a whole bunch of those things out there.
I think. Please go ahead, Danny.
Thank you. Yeah, no, I have a quick question as well. This is more related to where the project itself is going on, within the future steps. At least at NBNL, and I think in some of the other national laboratories, there is some interest in moving our pipelines to some more web-based kind of like settings. And I was wondering, because right now I have used Napari several times, and it's amazing as a viewer. It will be really great to integrate this with some of our pipelines so that as data is being collected, they can be processed at the same time. Is there some interest in moving the viewer to be kind of like a setting within Python towards either like a web-based interface or something within those lines? I was just wondering about that.
Yeah, it's one of our longest open issues. But it's super non-tricky. Super non-trivial or tricky. Because so much of it is based on Qt, but we're moving to auto-generating a lot of our UI with this thing called Magic GUI that you saw. And the more that we can do that, then the easier it will be to then just generate a bunch of widgets as a web view using, say, SciPy widgets instead of Qt as the front end and put it on. And there is a demo of having the canvas be a live canvas without having the widgets available. That's an open PR right now on our repo, which is really cool, using this Jupyter RFB stuff that Elmer Klein and the VisPy folks have been doing. An alternative to that you can use right now is this thing called Jupyter Desktop, which is to have a whole virtual desktop in your web view and have Napari appear there. And I know that people are using that right now in a lot of places. So that's what you can do right now. It's a little bit clunkier, but it works.
You have people in your ecosystem bump into the limits of auto-generated GUIs and what Magic GUI can do, and building like native Qt extensions as well. Yeah.
Absolutely. Yeah.
Yeah, definitely. I think, I love Magic GUI because it's so quick, right? You can just have a Python function, provide type annotation, and you have a widget in a couple of minutes. You don't actually have to build a plugin. You can just have the widget added to the viewer in a script as well. So you don't even have to go to making a package. But I don't think I see Magic GUI as the ultimate solution for building GUIs, right? Because there's only so much you can do in an auto-generated fashion. And, we have pretty complex plugins up on the Napari Hub at the moment that, multi-step, or that allow you to, select what your data looks like and do a whole bunch of sort of more complex pipeline processing. And while we want to move towards like composable magic GUI widgets where you can just pipe it the way we saw that data frame earlier. I don't think Magic GUI will ever be at the level where it can just replace a full-fledged, widget building tool or GUI tool. And I don't think it's intended to be either.
So, I have a question along the lines of Tanny's. Maybe it's obvious to you guys, but I installed Napari myself, and it was really easy, and it worked on my Mac, and I thought, oh, this is great. But then, like, all of my data is on a remote server somewhere. So, is remote data access an easy thing to set up in Napari?
Easy is a strong statement, but as you saw, you can look at any desk array, and desk array can do any remote operations. So it really depends on how your data is accessed. If you have like data on an S3 bucket with ZAR, then ZAR offers options to load that in. I have this work in progress blog post that I've never published, but I was able to use SSH to SSH into my institutional cluster and like open a file and access the array that way. So yeah, because you can put arbitrary computation into a desk array, the answer is yes, you can do this. But it really depends a lot on how you access your data. But accessing remote data, for me, was actually the original vision of like remote, rather than having web widgets, is to just be able to access your data using a local Python client.
I will plug a Napari discourse issue that we opened that I think I can put into the event chat, where because you can do arbitrary things with desk arrays, we're integrating our data access service tiled with Napari, with the goal and the outcome being a plugin that lets you search your data and pull up the slices that you want, and a tutorial to go with that to say, this is obviously not the only way to do remote data in Napari, but is a way that may be interesting. Not just the user facilities, but to the graduate students with buckets of TIFFs that want to run a remote data server the same way they might run a Jupyter server on their institution and then connect to it from home. So I think there's a lot of potential there. A lot of fun things that we can do with that.
Yeah, the other thing is
I was going to say, if you are playing with things and you do manage remote data, welcome contributions. So, if you have a little tutorial or a little notebook that you've run, definitely get in touch with us on GitHub, and we'd be happy to turn that into a tutorial that we have as part of our sort of broader documentation suite. And I know that, Daniel, you've been wanting to do that. So yeah, definitely don't be shy.
I was going to say, you can make a reader plugin that takes in a URL and then does a whole bunch, does all of the data loading for you. So, yeah.
Perfect. Well, if we have any more lingering questions, now is your time, host panelists or guest panelists. If you have any questions you want to ask our host panelists who have development experience of their own, now is the time to ask, as we are approaching the end of time. All right. And if that is everything that we have for today, I would like to extend a huge thank you to both Juan and Draga. Fantastic demonstration. It always blows my mind what you can do with Python, the types of things that you can make with it, right? I use pandas data frames. Cool. I'm not making three-dimensional image explorers that, can process loads of data. Absolutely fantastic. Thank you so much for joining us here today. And a huge thank you to our audience for joining us here today as well. To prep you all, as just a little teaser for next month, we will be joined by Emmanuel Lafosse, who works a little bit on the Jupyter notebooks, and he will be sharing with us how you can write your own custom completer, as well as some of his more personal work on process variables as part of the EPICS protocol, and that's the Experimental Physics and Industrial Control System. Until then,
what's a custom completer? Sorry.
A custom completer. It's right, your auto completer, right? When you're trying to tab complete, and sometimes it doesn't work, sometimes it does. Emmanuel's been working on that as part of the ethics. So make sure that you tune in with us next month. And until then, I hope you all have a very wonderful month, and make sure that you are staying tuned to our website, meetup.doepy.org, for updates along the way. See you all next time.